When doing math, an instructor will often assume you have background knowledge. And usually you have it, but sometimes you don't. You might be missing some details. One thing that I have found is that many people get tripped up by some fractions. I will write the same expression in two different ways and they won't recognize that it's actually the same expression. Now you're probably fully familiar with things like 1/2 equals 2/4 equals 3/6, etc. Those are all different ways of writing 1/2. But when letters come into it, when you have, say, A times B over C, there are many ways to rewrite that expression. Let's just run through some of them. In my head, when I look at this, I see there's an A times a B, and there's a C on the bottom. That's how my brain parses it. That's how I split it up. So if I see A times B over C, that's an A and a B with a C on the bottom. That's all I see. If it was B, A over C, exact same thing. There's a B and an A on top and a C on the bottom. A over 1 times B over C, same thing. Dividing by 1 doesn't change a thing. B over 1 times A over 1 times 1 over C. Again, an A and a B on top and a C on the bottom. I parse all of them the same way. The reason to have so many ways to write an expression is that sometimes one is more convenient than another depending what you're trying to do. So it's like having different tools in your toolkit. So use whatever is easiest. If you have more tools, you pick the easiest tool. Lots more ways we could write this. We could write A, B, C to the -1. C to the -1 means 1 over C. So that's another way of writing the exact same expression. We can put them in whatever order we want. 1 over C times BA. You could even see things a little more oddly and have C over AB all to the -1. Because raising a fraction to the -1 power means flip it over. So C over AB all to the -1 means AB over C, which is the exact same thing we started with. A could be written as the square root of A squared times B over C. We could write the whole thing under a square root, A squared B squared over C squared. The possibilities are almost endless. We've got, all the different orders we could write them in. It doesn't matter what comes first, the B or the A or the C. All that matters is that the C is registered as being on the bottom and A and B on the top in the numerator. All of these are equivalent expressions, and I'll just shift between one and another, won't even notice that I've done it. So as you can see, there's many ways to write a fraction like AB over C.